Hello, I'm going to show you about the moving platforms. I'm going to give you a quick demo. So you can see that they're moving around, moving and grooving. They are rendered per frame, so they should look very smooth on any refresh rate. And you can see that if I pause the game by opening the chat, the platforms also pause. And there are also interactive platforms. So you've got a button that makes this hydraulic press with a kill part come down. And it's supposed to kill you, but it just kind of doesn't. And it makes you go through the floor. Fantastic. And then you also got a elevator with calling buttons. And I can send it off by pressing the third button. It goes up to the top floor. Amazing. And the elevator also pauses when you pause the chat. Let's ride the elevator up to the top floor. Yep. And that happened. Fantastic. Okay, now I'll show you how they're set up internally. So for the analytic moving platforms that aren't interactive, it's a module script called analytic that modifies the parent object. So this is the one that goes back and forth linearly. I think I don't need this on my mouse now. And then this is the one that goes sinusoidal back and forth. So it's rather complicated, but you can just copy and paste from my code or ask me for help if you want if you have a specific moving platform idea or an idea for a death run trap. You can contact me and I can help you out with the specific implementation. How it works for the analytic moving parts is that it returns a function that calculates a motion equation. So this is the motion equation for the forwards and backwards platform that just moves back and forth. It grabs the position of A part, grabs the position of B part, makes some Lucas vectors, and T is the value for time that gets filled in using the game code fills in the value of time later. It generates an equation, an unevaluated equation, and that's how it operates. So this equation is moving back and forth from A and B. Every 3 seconds it goes from A to B and then back to A for another 3 seconds. So 1, 2, 3. 1, 2, 3. And that's the equation that represents that. And it's passed into, or it tells the game to modify the position of the parent object, which is this platform. And then A and B are these position identifying parts. You don't really need to have them. You could specify the positions manually, but it's way easier to have those. Okay, and then in the spinning example, you can see the spinning platform over here. Where is it? Right here. I've got another analytic module script that modifies the parent object. And this is using quaternions and axis angles. So it says the rotational velocity is 2 radians per second in the y-axis. And then it uses this quaternion exponent function, which you don't really need to understand. This is basically how all spinning platforms are going to work. The rotational velocity times the current time. That makes an axis angle. And then it does quaternion exponentiation. And then it composes that orientation with the original C frame represented as a quaternion, which doesn't matter too much. It just it spins the part around its own vertical axis. So you can just use that for anything spinning, really. You can just copy and paste this, and it'll spin. And you change this number, it spins faster or slower. And then you can see the hydraulic press. Let's see that in action again. Come up and you click it, and down it comes. Did I already show it? I don't know. Well, that's what happens when you click it. And so I have it named kill, and then the button is called button 1. Let's actually look at it. There it is, button 1. And then the part that it is operating on is called kill, because I want to make it a kill part. And here is how interactive moving parts work. You have an instance initialization function. It grabs all the needed values, like the velocity it wants to use to move this down with a velocity of 1 stud per second. It's got the initial position of the part, which is grabbed outside like this. And then this is how long it takes to go down. And this is the final position of the equation. So here is the activation function, which is called when you press the button. It gives you which part the button is, and it gives you the time of activation. This particular example returns a piecewise function. The first piece is when the time since activation, t minus activation time, is less than the time it takes to press down. So for the first 10 seconds, it runs this equation, which says that the position is equal to the initial position plus velocity times the time since activation. And then the second piece is this final piece, which always evaluates to true and is the final position. So you can see it stopped moving. That's the last piece of the piecewise function. Okay, now this one is probably the simplest example. It's just a part that disappears when you press the button. There it is. So in that example, let's find it. We have a button. We have a part, which happens to be called surf. You can call it whatever you want. And then we have the interactive module script. And inside the interactive module script, button 2 activates interactive 2. We have the instance initialization function, and it just directly returns the activation function, which is called when you press the button. So this is called at the beginning of the game, or whenever your map is loaded on each client, calls this function. And it also calls it once on the server side for each bot that is running. But it doesn't actually matter in this example. So you can see that it sets the can collide to false, and then it sets the transparency to 1. And that's the function of the activation function. And then the elevator is even more complicated than the other examples. Let's find the elevator. So I have lots of different buttons for activating it. I've got these buttons on the floors, and I've got the buttons in the elevators. So the first thing the script does is write down which buttons correspond to which floors. So it does a loop for each floor. It knows that there's 3 floors, and then it writes down the elevator button means floor whatever, and the floor button also means floor whatever. And then in the activation function, it uses whichever button was pressed to detect which floor it should go to. So it just like indexes it, and then it gets a whichever floor, and then it grabs the floor position, and this is the final position of the thing. And it does some math to make a nice equation so that the elevator speeds up and slows down as it approaches the floor, and then it creates a piecewise function. So this is the speeding up bit, and this is the slowing down bit, and then this is the sitting at the floor piece of the piecewise function. So when the time since activation, TA, is less than the time that the two parabolas meet, then it does the first parabola, where it accelerates towards the target floor. And then if the time since activation is LT is less than, I should probably say less than, less than T1, which is a calculated value, the time the elevator finishes. If the time since activation is less than the time that it finishes, then it does the second parabola, which is the slowing down parabola. Otherwise, for all other times, it's just sitting at the target floor. So we can see that in action. Click, it speeds up, it slows down, it sits at the floor. That's a piecewise function. We can also ride the elevator. And it did that. Fantastic. So yeah, that's moving platforms in a nutshell. It's pretty complicated, but you can just contact me and I can help you out with whatever you need to make. I hope you can be creative with this analytic system. It's very mathematical and it's completely reproducible. So every single speedrun, if an elevator is part of your speedrun, it's completely reproducible in the bots, and I can verify whatever happened by rerunning the simulation. It's really neat. So yeah, contact me if you need help with moving platforms, and good luck with making Deathrun and bhop and Surf maps with the new moving platform system.